Alright, ladies and gentlemen, remember how everything we do in here thus far has kind of been an advancement or a revisiting of things from Algebra 1? Well, think back. Even better than graphing, even better than systems, what was your favorite thing in all of algebra? That's right, factoring! Yeah, I know you're excited. Alright, to understand factoring, all you have to do is realize that it's the literal opposite of simplifying. Right? Like we FOIL this, as some people say, by multiplying the first term times the first term. That'd give me an x squared. O means the outside terms. X times positive 2 is plus 2x. The I in FOIL is the inside terms. Positive 3 times positive x is plus 3x. And finally, the last terms, the 3 and the 2. 6. That's not our final answer because this can be, the 2x and the 3x are like terms, so they can be combined. I still have the x squared, but these two become plus 5x, and we still have the positive 6. So x squared plus 5x plus 6 is the simplified version of x plus 3 times x plus 2. Factoring is the inverse of that. It's the reverse process. It's taking the simplified form and putting it back into the split form, the factored form. But if you look what happened with the 3 and the 2, something special happened. We did 3 times 2 exactly once. So that multiplication ended up right here. The last number represents the product, or the answer to a multiplication, of the two numerical terms. The first one is the product of the first terms, x times x. The only odd one was the middle term that was a combination of these two things. But look, we ended up with 5. 3 times 2 is 6. 3 plus 2 is 5. The trick to factoring is to figure out two numbers that multiply to be your last term and add up to be your middle term, the coefficient of the first degree of the x. One more time. Two numbers that multiply to this one and add up to this one. So let's try another problem in that vein. What if I said x squared plus, gotta make it up on the spot here, 7x plus 12. Now we're going to start off easy here and always have 1 as our lead coefficient, right? Or a value, if you will. It's just going to be 1. That doesn't leave us with too many options. There aren't very many ways you can multiply and get x squared. It's either 1 times x squared, which wouldn't help us factor at all, or it's x times x. What's left in that problem? Well, we have to figure out two numbers that multiply together to equal 12, and they add up to equal 7. If something just pops into your head, that's fine. Put it down. If you're stuck, start listing all the ways you can multiply and get 12. There's 1 times 12. There's 2 times 6. There's 3 times 4. And if you were to add those together, that would be 13. That would be 8. That would be 7. We have a match. So it must be these two numbers, both positive, plus 3 plus 4, and that is the factored version of x squared plus 7x plus 12. Now both the ones I gave you true were all positive terms, which does make it a little bit easier for most people. So because your homework's going to test you on about everything, let's make sure we can do even higher level ones. So let's say x squared minus x minus 6. Alright, and depending how your brain works, a lot of things could be happening right now. We see that this number is 1, which would tell a lot of people that our two numbers have to be 1 apart. If that doesn't make sense to you, don't you worry. One thing we have for sure, though, is our last number, the one that's our product, the result of multiplication, is negative. And if you have a negative value, that's the result of a positive times a negative every time. A positive times a positive is positive, a negative times a negative is positive. So if your result of a multiplication problem is negative, that means one of your terms is positive and one of your terms is negative. So we have to think of two numbers now that multiply to 6, whose product is 6, and whose difference is 1. In other words, they're 1 apart. Well, 6, there's not a lot of ways to multiply and get 6. 6 and 1, 3 and 2. The difference between 6 and 1 is 5. That definitely cannot be our answer. The difference between 3 and 2 is 1. So that must be our values, 3 and 2. But which one goes where? If I put the 3 here, positive 3, and the 2 here, positive 3 and negative 2 make positive 1. And that's not what they need to add up to. They need to add up to a negative. In other words, the bigger value must be negative, the smaller value must be positive. The 2 goes here, the 3 goes here. X plus 2 times x minus 3 is the factored version of x squared minus x minus 6. That's all there is to it.